Welcome, welcome. This is the first video of the set 81-82, and let's squish on there 83. So let's take a look. The first question, 81, goes something like this. The correlation between the x and the y is 0.8. If x and y are converted to z-scores, see it says z-scores, then what would be the correlation factor? So right away, we've talked about if x and y are flipped, then it would still be a positive correlation, but it might be something else. No, that's slope. So if x and y are flipped, the correlation factor stays the same. The slope might change slightly, but it would still be a positive slope. So the correlation factor would be E if the question said x and y are flipped, but it didn't. It said x and y are converted to z-score. So to do question 81, I decided today to make a sticky. So I make a little sticky for what it would look like if R was 0.8. So R of 0.8 would mean the dots are fairly close to the line, and because 8 is positive, I know the slope's positive. But now they said, what if you took each and every little value of x and y and you made that a z-score? Well, this is the formula for R. So that is the correlation factor R. And so when I look at the formula here, I notice that, that's how they calculate R. They take 1 divided by n minus 1, and then they sum or add up all the x z-score times a y z-score. Then do it again. So each little dot, they do the x z-score times the y z-score plus the x z-score times the y z-score. So if you plugged in the z-score, sorry for the bell, if you plugged in the z-score, which you're kind of doing, if you plug in the z-score, you're going to get the same value for R. So the answer here is E, stays the same. I wouldn't expect a student to get this question right, but definitely a math teacher, we get crazy and we love understanding these formulas. All right, next question. Now this is actually more of an Algebra 2 question. Let's take a look. How does my mean and median change if I add 4 to the numbers? So let's take a look at my sticky here. It says the mean was 49 and the standard deviation was 14. So I made up a possible scenario of this. It'd be like the middle number is 49. If I subtract 14 and if I add 14, I get 3 possible numbers. So I don't know that there were 3 numbers in the number set, but let's just say there was. So the average amount that a typical number varied from the mean is 14. Now let's take my raw numbers here in purple and add 4 to them. Notice my mean goes up by 4. My mean is now 53, and the amount that each number varies from the mean on average is still 14. Remember, we don't add standard deviations. No. We add variances. So these are not variances, right? And the standard deviation doesn't change when we add or subtract. It does change when we multiply or divide, but we don't multiply, we add variances. So we square it and add. Okay, next question. That was definitely A. What is this last one? A again. Let's look at my sticky I made. The question states, you are being asked to do a 95% confidence interval where they give you the standard deviation 3.01 and they tell you the number in this sample is 11. So right off the bat, you know the statistic. This is right off of this formula sheet here. So you're like, what? That's on the formula sheet? Yep. Right off the formula sheet, the formula for a confidence interval is the statistic plus or minus the critical value times the standard deviation of this statistic. And then they tell you the standard deviation of the statistic is this or that, depending on if it's a mean question or proportion. So plugging in this here and looking in the table to get the critical value. So let's go back to my sticky. My critical value goes here, my mu goes here, plus or minus critical value. So looking in the table, I got a mean question, not a proportion question. So I use the mean calculation for the standard deviation of the statistic, and I'm able to kind of eliminate some choices just by that. I definitely don't want C or D. And E's no good either. So I'm basically narrowed it down to A and B. And the only difference between these two is the critical value. So I got to be really careful. The critical value from the table is calculated by the degree of freedom, which is n minus 1, which is 10. That's where the number 10 comes from. And when I look it up for the 95% confidence interval, I get that number. That's why I got A. I'll let you look at that sticky. So where do I find that number? If you're still confused about the table, that's okay. We'll clear that up for you. I'm looking at my table. I notice down here, here's my confidence intervals, but I can only use these if I have a proportion question or I have a whole bunch of numbers. So that's why I have to use the degree of freedom of 10. Scoot on over here till I get to 95. Where's 95? Here. Scan on up to there. And there's the number I'm looking for. That's how we found that number. Thanks for joining us.